before we jump into the fourth phase of water, I'd love for you, because weather and all the impacts of weather are so prolific today. And what is going on our planet with the floods, the droughts, the earthquakes, the hurricanes, tsunamis is, I call it's biblical. It's so extreme of what's happening. Tell us, tell us what's happening, Jerry. What
Oh,
is
well.
Mother Nature? What is Mother Nature telling us today?
So I claim no expertise in the change of climate, but I think I do know something about weather. And if you want to find out about climate, you need to know something about weather. And to my surprise, if you want to find out about weather, you either you look at Wikipedia or look at some textbook and try to find out from first principles what creates weather. And I tell you, it's really frustrating to look and try to find out. You can hear about low pressure and high pressure, but that doesn't start from first principles to allow you to know. So what we've done, what I've done, coming out in my next book, is to try to understand how it works from first principles. And I tell you, to my surprise, I was in an interview with an atmospheric scientist, and there was a break in the interview. And during the break, he told me, "I got to tell you a secret. The atmospheric scientists, they don't understand at all two of the most fundamental issues that are related to weather and climate. First is evaporation, and the second is cloud formation. And my goodness, if you don't understand evaporation, and if you don't understand how clouds form, what do you understand? How are you going to figure out? And how do you know? I mentioned in Seattle, we have in the wintertime these dark gray clouds looming above. And we don't know if it's going to rain. The forecast says, well, 50% chance of rain. That's great. It really helps you to know whether you should take a raincoat to work or not. And it's odd. I mean, don't you think it's odd that in this day and age, nobody can tell you whether a gray cloud is going to unleash its contents as rain or not? What turns on the rain? What switch? So these are features that nobody understands. And so, I have tried in my forthcoming book to produce an understanding. You think you may have learned something. You may have learned something about evaporation. So if you learned something, what you probably learned is that the water molecules evaporate by one molecule at a time, and they get a kick of energy. I can't remember, kinetic energy, potential energy. You get a kick of energy, which releases them from the liquid water, and they evaporate. There may be some truth to this, but it can't be the whole story. And the reason it can't be the whole story is if you've ever gone to Starbucks or equivalent, and you see all the people around you and their hot coffee, you can actually see the vapor coming up. You probably noticed that, I think.
Yes.
Yeah, and it doesn't have to be Starbucks, but Starbucks was born in Seattle, so it's we refer to it incessantly. But if you can see it, if you can see the vapor, essential basic physics tells you something. In order to see something, that something needs to be roughly the size of the wavelength of light. Now, the wavelength of light is a half a micrometer. A water molecule is so much tinier than that. And so just in the same way that you can't see the air because the molecules are so small, you can't see one droplet or one molecule of water evaporating. It has to be a giant cluster. And if you calculate how many water molecules are in the minimal size cluster in order for you to see it, I calculated it once. It was something like 1 billion or something like this. And the fact that you can actually see the vapor coming up means that the water that's evaporating to constitute that, it has got to be billions of water molecules coming up together. And, you know, that means that the conventional story of evaporation can't be correct, or at least it can't be complete. There's something else. And we studied that something else in the laboratory, and actually it's presented in the book that you mentioned, the fourth phase of water, that when the water evaporates, it evaporates in clusters. Now, that may not be the full story. There may indeed be individual molecules of water coming up, but if you want to understand weather, you need to understand evaporation. And if you think evaporation is simply one molecule at a time, you'll never get the right answer. and so you might say that's a kind of starting point. And then you get to the issue of clouds. What is it that makes a cloud? You know, you can see in a bright blue sky, you can see a white puffy cloud, and immediately next to it, there's nothing, or nothing that you can see. And how does that happen? You know, and I don't, I guess in order for me to explain that, there's a lot of background material. So I'm not sure how much time we spend on this, but it is possible, and it's not very complicated to explain how a cloud forms. And you need to know in order to understand about weather, you need to understand how clouds form. And so I guess I don't want to go into detail at the moment. It's not very complicated, but it's 2 or 3 steps, and I'm not so sure. There's one principle though that I should mention, and I think the principle is central. And as far as I can see, nobody has ever alluded to this principle. So the principle is, it comes from the great physicist Richard Feynman, who many people consider to be the Einstein of the second half of the last century. He also had a sense of humor, which maybe is part of is responsible for a portion of his success. We don't know that, but he elaborated a principle, and it's called like likes like, because of an intermediate of unlike. So what on earth does that mean? Like likes like. It means if you got 2 charges, and the 2 charges are like charge, they're the same. Let's say they're negative charges. If I were to ask each one of you to predict, if you put these close together, what would happen? And I bet you that every one of you would say, well, of course, they're going to repel each other because they have the same charge. They're like charges. However, if these charges are sitting in water, the observation is they come together. They don't repel each other. Now, that would seem awfully mysterious, but Feynman figured it out. He said, if these 2 are, say, negatively charged, the reason they like each other, the reason they come together, is because of unlike charges in between. And what was missing from Feynman's assertion that this is the case is, where do you get these charges that lie in between, these unlike charges? Likes like, they come together because of an intermediate of unlike. So you got 2 negative charges and positive charges in the middle that pull the negative charges together. And that principle, I believe, is the main principle underlying cloud formation. The clouds occur because these large clusters of water that have evaporated, they've got the same charge, negative charge, and they contain easy water, which we haven't talked about. But when easy water forms, it's negatively charged, and together with that is the formation of positive protons. And so you got these negative charges surrounded by negatively charged easy water. Protons are released, and the protons have the highest concentration in the middle, so they pull these droplets, these clusters together, and that is one of the main underlying principles. No, so
Thank you, Jerry.
I don't know if you want to go on to other, but I you know,
Let's
what makes it rain? What decides if it rains or doesn't rain? And so happy to discuss that, but if you want
well
to go
let's
on to some other stuff, we can
yeah,
go.
let's come from the clouds down back to earth.
Okay.
And let's come to our bodies and let's talk about this fourth phase, this gelatinous phase of water, as you call it, easy water. And could you share with us about how does that exist in our bodies? What is the function? And maybe in nature as well.
Okay, those are big questions. Question number one, it fills our cells, and it's a gelatinous, as you say, kind of water. We call it fourth phase water because its properties are different from every other phase of water that we know, solid, liquid, or vapor. Um, in one of and it's a kind of water where in which the molecules are ordered. They're not, you know, in liquid water, like the stuff we drink, the molecules are randomly oriented and they're bouncing around a fierce number of times per second or even per femtosecond. That's this water. But in the EZ water or fourth phase water, we call it EZ because EZ is for exclusion zone, and it has to do with the fact that this ordered phase of water excludes everything. It's a pure crystal, liquid crystal. And the way you can determine that your body's full of it, and not liquid water. We learned from the textbook that our cells are filled with liquid water, but all you need to do is take a razor blade if you're brave enough and cut yourself. So you cut yourself, and what comes out? So you know, obviously blood comes out, but if your cells are filled with ordinary liquid water, then the water would come out in the same way as from a breached water pipe, and you've probably seen that. It comes out, but it doesn't come out of out of the cut in your body. And surgeons I've spoken to say the same thing. You know, deep inside our bodies, they'll cut through a muscle, for example, and the water doesn't come pouring out; it stays in. And so the reason it stays in is the water is this special type, and it's stuck to the solids inside the cell, so it stays in. It sticks like a gel would stick. It's gel like. So now in terms of function of this water, and I would like to assert that the function is to supply energy. Now you don't ordinarily think of water as being an energy source, all right? But we found that it is, and we found in experiments that we did more than a decade ago is that this water builds next to surfaces. If ordinary liquid water sits next to a so-called hydrophilic surface, water-loving surface, that liquid water undergoes a transition. It transitions to this fourth phase water. And to our surprise, we stuck electrodes in this fourth phase water, which can be pretty extensive. We stuck electrodes in, and we found out that typically this water is negatively charged. It's not neutral. So you start with neutral water, and the neutral water transitions to this negatively charged EZ water. And so there's something wrong here, right? Because you can't, out of something neutral, you can't get to something negative. The only way that could happen is if somewhere else there's something positive. And then we found that indeed that next to this negatively charged EZ fourth phase water sits protons, positive charges. So what's really going on is that the water is getting split. It gets split into OH minus and H plus, and they remain separated. You wouldn't expect them to remain separated because we all learned in middle school that negative and positive attract one another, and all they want to do is get together, fuse into something neutral. So why does that not happen? The reason it doesn't happen is this easy structure is so dense that although the positive protons want to penetrate, they can't because it's just too dense for it to happen. And so they remain separated. Now, if you've got negative and positive that are separated, you have a battery. And so in our bodies, we have batteries. And the critical, or a critical finding is you can't get a battery out of nothing. You can't get something for nothing. Even in Israel, I think you can't get something for nothing. But although people try. So we found there is an energy that creates the battery, and that energy is light. It's infrared light. Infrared light is all around us. We generally call it, not quite appropriately, heat. Heat produces infrared energy. So, if you turn on the electric oven and you open it and you see the glowing red, orange coils, you feel heat and you see the glowing coils and you say, well, it's generating infrared energy. But infrared is all around us. Everything is generating it. And you could tell that that's the case by taking out an infrared camera that is just like a regular camera, but the sensor, instead of being sensitive to visible light, it's sensitive to infrared light. It can be completely dark, and you get a beautiful image of everything, which means everything is generating infrared light. So the source of energy for building or recharging this battery that I mentioned is all around us, which means the battery is always there. It's inside our body, and it provides energy. So I can go on, but I'll let you guide the conversation, Stuart.
As you say that, we all have heard that you can't live without water, and that water, you can live with only water and you don't need food. And I'm wondering, is this energy an explanation of why you can live only on water? And last month we had a extraordinary man talking about, Lauren Lockman, talking about water fasting and how people can live on water fast for 21 days without any food whatsoever. Is the reason we can live on water alone because of this energy?
Yes, I think so. Just a few days ago, I spoke with a woman who goes by the name of Jasmuthine, who lives in Australia, and we were chatting, and she's been on a fast, so to speak, so it's called breatharian, eating no food for years and years, and she conducts actually a kind of a workshop or schooling for other people who want to go on this. And so there's been documentation from numerous people. I think she mentioned that in the whole world, she's aware of a few 100,000 people who do this on a regular basis. They fast indefinitely. And so, of course, the question arises, the question you bring up, where on earth do they get their energy if they don't eat? Well, they can get their energy through light. And many of these people who do this are spiritually oriented people. And I wondered myself whether spiritually oriented people have maybe a higher capacity to absorb this kind of energy from the environment. And and if we're right that the easy water in the body is essentially a battery providing energy, and we've documented the use of this kind of energy in the body, perhaps that's all you need. You don't need food to do it. And if all of us were to engage in that practice, the world might be in better shape. So plants do it all the time, right? Plants, they get their energy from light. And so why would we not get energy from light? If
Photosynthesis.
if you're Mother Nature, and you've thought, well, I've been pretty successful with unicellular organisms and green plants, and photosynthesis has worked pretty well. I'm going to invent animals, uh, and you had an option. You could retain this energy deriving mechanism, or you could get rid of it. Um, and Mother Nature is pretty clever, and you'd think that that Mother Nature would keep it, either as your main energy source, or at least to complement other energy sources like energy from ATP or what. She wouldn't just throw it out. And so it makes sense that we could utilize this energy, and some of us even more than others.
Thanks, Jerry. As you talk about Mother Nature, you and I were speaking earlier about the intelligence, and we all have now been drawn into this world of AI and artificial intelligence, and how it is prolific and will affect every aspect of our lives. As always, it has its upsides and its downsides. And you and I were talking about maybe the beginning of intelligence, Mother Nature's, for water's intelligence. So share with us what the water's intelligence, and what is the foundation and power of that.
Sure. Well, I guess the first thing to say is that I don't think that ordinary liquid water has, if you say, intelligence or memory. And the reason for that is that water molecules, as I said earlier, they're randomly oriented and they're bouncing around, and it's hard to imagine situation like that as having any capacity to store information. But easy water is different. Easy water has two features which make it capable. And let me just say what those two features are. If you think about a computer memory, and you ask the question, well, what features does it have? And does easy water have similar features? Because there are two features in your thumb drive that you stick into your laptop. It has a series of transistors, and the transistors are in a flat plane, and they're very well organized at the points of a rectangular grid arrayed over a large planar space. Oh, easy is like that too. It not only has order in a single plane, but the planes are then stacked on one another in an ordered fashion. So yes, it satisfies that criterion. The second criterion is that in the computer memory, the transistors have two states, and they're generally labeled 0, 1, or on, off, or whatever. And the memory is embodied in the fact that this array of transistors, some of them are zeros and some of them are ones in some distribution, and that's what constitutes the memory. Well, in the EZ lattice, you have oxygens and hydrogens, right? Because that's what water is made of. It turns out that the oxygens have not 2, but 5 oxidation states. And the one that's most common that we speak of, we call valence of -2. That's what we learn in school. But if you read any chemistry book, this is not exotic or controversial. There are actually 5 states: -2, -1, 0, +1, +2. So easy water has as much capability or more than a transistor array in a computer memory. So in theory, all of the elements that are required for memory exist in easy water. Now, so you would ask the question, well, is there evidence that water can store information? And the answer I would give you is that there's abundant evidence that water, and I think it's easy water, that can store information. And it starts with, you might think of the spiritualist who many people know, Masaru Emoto, who passed 7 or 8 years ago.
Yeah. The memory of water.
Yeah, memory of water, right. Putting his attention to water, and scientists broadly do not accept his results. And I think one of the main reasons that his results are not accepted is that what he did was he put his intention to water, he froze the water, he looked at the water crystals that form, and if his intention was positive, then the crystals were beautiful, and if his intention was negative, then the crystals were gross, ugly. However, he would freeze 50 petri dishes of water and put his, say, positive intention to those 50 petri dishes. He'd examine each one and he'd pick out the best one. Now, scientists don't do that. And so at least scientists who I know don't accept those results, don't take them seriously, and even discredits the idea because of the way he did his experiments. However, I'm the organizer each year of the conference on the physics, annual conference on the physics, chemistry, and biology of water. We meet each year and we have 30 or 35 presentations, and usually 2 or 3 of those presentations each year deal with exactly that subject, water storing information, memory, a vast array of different techniques that are used to determine that there is such a thing. And at the other end of the scale, starting with Emoto, the spiritist, all the way to Luc Montagnier, who won a Nobel Prize, and as unfortunately he passed a year ago, but he came to our conference every year for more than a decade, and he presented his results, and his results are astounding in terms of the capacity of water to store information. So, he took some DNA in water in a sealed flask and put it near pure water in a sealed flask. And the two sat next to each other for a day or so. And his hypothesis was that the information from the sequence of DNA was somehow being transmitted to the water and stored in the water. And then he took this water and he tested it using the PCR method, which people know about because of COVID. And he found indeed that when he combined this water with the ingredients that are in the PCR necessary for the PCR technique, the DNA that emerged had the same sequence as the DNA that had been sitting next to the water. Astounding.
Even though there was no exchange physically, there was an exchange etherically. Or energetically.
Yes, right. And of course, that doesn't tell you what kind of energy there is, and the answer to that is nobody knows the energy. I mean, this finding was so astounding that I remember hearing the story of that. There's an annual meeting of Nobel laureates at a place called Lindau in Germany each year, and a dozen years ago, Montagnier was invited, and he presented his story, and I'm told that he was laughed off the podium. That all these other Nobel laureates said, "This is the biggest crap," if you excuse the expression. I met in Seattle with another Nobel laureate. We were having coffee together, and he told me the story. He attended this conference, and spontaneously, I told him, we've been dealing with water lately. He said, "Oh, I was at this conference in Lindau, and Luc Montagnier presented, and this was the biggest bullshit I ever heard." And so it was not well received. However, it's now been confirmed by 3 different laboratories, 2 of them in Italy and 1 in China, and published. So, if we take repetition as evidence for truth, then it seems true. And I mentioned Montaigne and I mentioned Emoto because you might say they're at opposite ends of the scale, starting with a spiritualist and all the way on to a Nobel laureate. He won the Nobel Prize for identifying HIV. Anyway, there's ample evidence for it. And, it seems exotic because nobody really understands the kind of energy that's involved.
Well, water is the most magical compound. And there's Dr. Martin Chaplin in London who has written extensively and discovered and created many scientific evidences of the anomalies of water, where there's over, I think, 40 anomalies of water that are just unexplainable. And sometimes we need to get beyond our mind, and we need to just recognize, as an example, most people have no idea how does this cell phone work, and how do we get a signal to this, and how do I talk with somebody in Australia over these chips. And so there's a lot that science can't explain at some stage, but in the future it does explain it. So I'd like to take time now for us to come together as community, and for us to break into small groups where we're going to have 3 of us go into virtual rooms together, and we will randomly select you and have you go into rooms together, because this is the time that we really value, is for you to get a chance to know each other and talk with each other and learn about each other and find ways that you can connect and you can collaborate in water and your passion and your value of water. So we're going to send you a link, and please click on that. It'll take you into a room. We're going to have 15 minutes together where you will be with each other and connect as you feel in your minds and your hearts to connect. And then Jerry and I will come into each of your rooms for short moments. So it won't be the full time, but we want to make sure everyone gets a chance to have a little bit of time with Jerry. And then after 15 minutes, we'll all come back together again, and we'll see what comes up. And we want to then have time where everybody in the community has comments, has questions, and that we begin to talk with each other and engage with each other, with Jerry as well. So we'll go to our rooms, and we'll see you soon, and enjoy your time together, making great connections with water.
I'll just say we had amazing innovators in our group. Drew's creating the water box, and Robert's creating underwater data centers to conserve water. And then the other Robert Scoville is working on NSF certification and the different contaminants in water to figure things out. A really great crew you attract, Stuart and Peter. Thanks.
Thank you, Mary. Well, let's talk about Mary. What Mary does.
Yeah, well, I welcome everyone. We're always promoting these HydroDAO events in globalwaterworks.org, and everyone can join the organization just by clicking globalwaterworks.org and seeing join the community. We also invite participation. We're doing rainwater harvesters in schools across India and lake restoration through a very innovative approach to using dissolved oxygen and enzymes in lakes, which finally works to eradicate the muck and algae that we've contributed over the last 50 years. Thanks, Stuart.
Thank you, Mary. Thanks for all your great work. Achim, I just love, you know how I always call on you because I like you and I respect you so much, and you being such a scientist, just love to hear any thoughts, questions, or comments you have about what Jerry shared with us today.
Well, I should disclose I've had a little preview of Jerry's book, so he was so kind enough to share it, and I gave him some feedback this morning. So there's something for everybody to look forward to. And again, another very inspirational book. I loved his first book, The Fourth Phase of Water. I think I got that about 5-6 years ago. And okay, originally I'm a hard-nosed chemical engineer, PhD, German engineer, educated. And Jerry's style and writing those books it's entertaining. It's really for everybody to understand these books. It makes it an easy read, but still very informative. I think some academics might take even offense with that, but for me, it opened a lot of things because he asks many questions in these books. He opens up a lot of areas where you can just then continue thinking about it, continue elaborating. One thing for me was I'd never heard of the Kelvin water dropper, for example, which is phenomenal. You can see loads of videos online about that, and that was very inspirational and had a big impact on my work that I'm currently doing, which is working on a very specific technology where I'm trying to convert heat into hydrogen, heat and water. So I love his work. It's inspired me now for the last few years. I always quote him. So it was very good to see him today, even though he popped in for a few minutes into our room. So I can only highly recommend it. It's good reading. It's reading for everybody. It's not academic science paper reading, but you will get a lot of ideas.
Well, thank you, Achim. You can be my press agent from here on.
Any comment or question you want to share, Achim?
I always have one burning question, but it's very detailed to Jerry, because in his fourth phase of water book, he's mentioned at some point that he was cooling water by vortexing it, but I never found any evidence anywhere about that. And that would have almost been a personal email to him at some point asking me, do you
Well, I've got to tell you, Achim, that I have the same opinion, that I've been looking for evidence that vortexing creates water structure, and the structure will be cooler than ordinary water because the molecules are not bouncing around at a fierce rate and generating infrared energy, and I can't find it. We did some experiments. The experiments were primitive, and I think I reported them in my fourth phase book. But people talk about vortexing all the time. But if you look for evidence for the effect of vortexing, I have the same problem that you have. You can't find it. It really needs to be studied. So thank you for bringing that up. Yes,
I tried it. I couldn't measure anything, and in the book it says somebody got it down to 20 to 40 degrees Celsius, so a massive temperature. And because I'm working on cooling large amount of waters, in terms of from a climate perspective, that would have been very interesting if there's somebody out there who can actually do that. But I'm following a different path to do that. So,
well, maybe you can do it. You
I
know,
have a way. Yeah.
there's a challenge because the measurements need to be made at the time the vortexing occurs. It may be that if you wait until after the vortexing has ceased, the properties may change, and you may not be measuring what you want to measure. So it's a challenge.
I wanted to say something about that at the water conference.
Yeah.
Yes, last year, I remember hearing from someone from the Aquaphotomics company in Japan. She made a presentation and she won. And their company actually did measure the effects of vortexing water. I forget her name.
Do you remember what their result was? That would have been Rumiana Tsenkova.
Yes, I forgot her name, but very unforgettable stuff. I know she talked about vortexing because I ran after her asking if there was a difference between the vortex direction.
Oh, okay.
But I know that she had measured that, and she measured light as well, but I don't remember the findings. So, but that would be a resource to go back to.
Yeah, sure, absolutely. So I can certainly ask, or Achim, you can ask as well.
Yeah.
Thank you for sharing that, Milena. Caden, I know you had a question, and it would be great for you to ask Jerry about this. And my thought is, Caden, is to ask it a little bit more broadly about alkalinity versus Kagan itself. But please go ahead and ask Jerry your question. By the way, I just want everyone to know that Caden lives in Maui, and as you all know, the devastation that has occurred there, and our hearts go out to Caden and the rest of the community in Maui. And
The whole water is like the main issue, is like the diversion of the water and the blocking of the water. And so it's a pretty intense issue that we're having drought when we're in one of the top wettest places in the earth. So it's very strange. And I don't like it, but it would be so amazing if they rebuild the whole water structure with a way that would actually energize the water and heal the water and heal that whole area. But we need the right people leading so for that to happen. But my question was just in general, Jerry, when you were talking about the negative charge of the water, are you using an ORP meter to get those? And I was just curious what you thought of Kangen water, because a lot of the Kangen people that sell it are always testing the water and it's making the negative charge. And you're saying, then that's good. It's a good thing, right? And I'm just wondering how that gets that. And I wondered what you thought about Kangen. And then I have another system that actually charges the water that way, but without electricity. So I don't know if that's a good enough question, but
Yeah.
Robert, I'm definitely not a fan of Kangen by a stretch of the imagination, other than the fact that they made such a big deal.
Who's talking?
that's Robert Slovak.
Oh yeah, okay. I thought we were talking. I was going to ask Dr. Pollack. That's okay.
Okay, I'll defer this to Jerry. He can comment.
Oh, you're down there. Okay, you're down there in the dark. Okay.
Okay. Yeah. So yeah, easy water is actually negatively charged. So in theory, if you're drinking water that contains a negative charge or a high pH, the two are actually the same. We just published a paper 2 years ago about the relationship with pH and charge, and we found this is on a slight tangent, but it's worth mentioning because people are confused by pH. So Kangen water has high pH, it's alkaline. And the question is, does that mean that the water has net negative charge or not? And I've asked this same question. I'm sorry if this deviates slightly from your question, but I've asked this question to numerous people who entered my office. We'd get into a discussion and I'd say, hey, if you have water that has high pH, does that mean it has negative charge or is it neutral? 50% roughly of the people said it's neutral, and 50% said negative charge. And I concluded from that nobody knows the answer, and it's not taught in school. And you could argue, if you have, for example, if you put sodium hydroxide on, the sodium valence of +1 and the OH -1, it should be neutral. You should have no charge. And other people think that you should have charge, and so we studied it, and we found out that the pH value is a direct indication of the amount of charge that's in the water. And to your earlier question, how do you measure negative charge in easy water? And what we did was to take a micro electrode, that is an electrode that has invented by Gilbert Ling and used by many people to measure the electrical potential of cells. And it has a very fine tip on the order of a micrometer or less. And you stick it into the cell. You stick one electrode in the cell and one outside, and you can measure the potential difference from inside to the outside of the cell. And you can then pull it out and the cell won't die. So it seems to be okay. And we use that electrode to measure the electrical potential of easy water. And we've done this numerous times. And that's how we measure the negative charge of the water. So going back to the Kangen water, I make it a habit when people ask me, oh, what do you think of this water? Or what do you think of that water? Of saying nothing. And I, and there are two reasons for that. One reason is that if I were to endorse a particular kind of water, that takes a stand, and I, as a scientist, I prefer to remain independent of any commercial product, because then my integrity is compromised. And the second is, I don't really know. I can tell you theoretically what I think should be the case, but in the practically speaking, I can't say. I think the only way to really test if Kangen water or any other water is good for health is to do clinical trials. For example, you take a bunch of patients who, I don't know, let's say have stomach cancer, and 50% of them you give water A and 50% you give water B, and you compare what happens after say a year, and that way you can determine if one water is beneficial compared to another. All we can say is, from a theoretical point of view, Kangen water has high pH, it has negative charge, and because of the negative charge, in theory, it should be good for health. In theory, because we need negative charge. Negative charge environment is helpful for us and keeps us healthy. So again, from a theoretical point of view, it should be good for health. From a practical point of view, I can't say, because it's never been tested. Or I should say, I'm not aware of the tests. In Japan, I'm told that many tests were conducted, and because the tests were so positive, and I communicated with a scientist who spent most of his life involved in testing, is so positive that the Japanese government now, if you have any gastrointestinal issue from your mouth to your anus, anywhere along the way, the government pays for you to drink Kangen water.
Wow.
Yeah, and so that's as far as I can go. I
Well,
also know that some people, for example, Mercola on his website is talking about some negative impact of this kind of water, and I haven't followed it directly. So anyway, a long answer to a short question.
Yeah, well, I think every human is so unique that it works with some people's chemistry and other people it doesn't. So, because I've heard these stories each way.
Yeah, Robert, you want to chime in?
Yes.
Stuart, my connection is so bad that I'm really not even anyone is saying. So it's unfortunate, and I'm not even sure what the issue is. I know it's about ORP and pH and so on, and the ORP of water is really that is measured by devices like Kangen, is really due to the hydrogen that's generated from the electrolysis process. It's very simple. You just get there and you can see what happens. But all of these waters, people just do not understand what happens to these waters' characteristics when they enter into the esophagus and then descend into the stomach at a pH of 1.
Robert, unfortunately, you are breaking up, and I'm sorry, because I would love to hear, and I know our group would love to hear what you have to say, because it's really critical and very important from your understanding of both the pH and alkaline versus alkalinity, which you and I have spoken about before. So maybe you can share that, and we'll share that with the group thereafter, since we're not able to hear you.
Let me just make a comment about the stomach acid.
Yes, please.
You'd expect that any advantage, if there is an advantage, any advantage of some alkaline water would be compromised, because the stomach acid it's acid, and so it should neutralize the alkalinity of the water that you drink. But what people don't take into account is that the volume of stomach acid is really small. So if you drink this much alkaline water, and you've got maybe 1 cc of stomach acid in your stomach, there'll be some neutralization, but not a whole lot of it. So it really depends on the volume of water that you drink, the volume of alkaline water. Now, that doesn't necessarily mean that I'm advocating alkaline water, but I think it's an issue that should be clarified because many people talk about it. Volume matters.
Well, I know Robert is a big fan of molecular hydrogen and the increased levels of that in water and the health benefits for that. Are there any comments and insights on that, Jerry?
No, I really haven't followed that in enough detail to make any intelligent comment. Sorry.
So one question about, as you talked about, you essentially shared with us that higher pH levels have higher electrical charge.
Yes.
That's not a logarithmic scale, right? It's I don't know what the right word is for that. So our pH is 7.4 and in our bodies. So whether it's 7.8 or 8 or 9 or 11, what's the difference of potential charge in those higher and higher levels? And could it be so much that it could be overcharging us those levels of pH?
Well, I can't comment on overcharging us, but we found an absolutely direct correlation between pH and electrical charge. The two mirror one another exquisitely, and a lot of people think that it's impossible for let's say a glass of water to contain electrical charge because it should be neutralized by positive charges in the environment, in the air. But we found that it's not, and that pH is a bit complicated to comprehend. But charge is really easy. You take a glass of water and either it's neutral, and if it's negative, it's got an excess of electrons, and if it's or high pH, and the higher the pH, the larger the concentration of electrons that are situated in the water. It's actual charge of water that counts, and our bodies are filled with negative charge. We're actually negatively charged bodies, and if we lose some amount of negative charge, then we're not as healthy as we might be. And so any kind of infusion of negative charge is going to be helpful for us. And there are various studies that support this point of view. And so I can't recall what was your initial question, but I just would like to emphasize that we're not neutral at all, and it's a pity that Benjamin Franklin called electrons negative, because you translate negativity leads to positivity in terms of health. And it would be great if it were the other way around, and if positive charge was positive for health. But unfortunately, that was Benjamin Franklin, and we I guess we have to suffer from.
We live with it.
Yeah, live with it.
Yeah. As you speak about that and the positive negative charge, I think it'd be fascinating. Some people talk about we should have higher levels of oxygen, and that higher levels of oxygen are better for us. And the oxygen is a positive charge. And many of us know and understand that oxygen has many isotopes, and that, quote, oxidation is a health aspect that negatively affects our cells from oxidation. Might you just talk about that?
Yeah, well, I think there's there's something questionable in the line of reasoning. Um, See, we certainly breathe in oxygen, and the question is, does that oxygen actually get from our lungs into the blood? And a number of anomalies arise that lead to the suggestion that it's not actually the oxygen that gets into the blood, but electrons drawn from the oxygen. And I just submitted a manuscript describing that. And just a few of the considerations. I know this is highly unorthodox. This idea that it's not oxygen that gets into our blood, into our capillaries, but electrons from the oxygen, leaving the rest of the oxygen with positive charge that we then exhale. And one of them is, what about nitrogen? You know, nitrogen is a smaller molecule than oxygen, and the air is filled with nitrogen. It's roughly 80% nitrogen. So how come we don't breathe mostly nitrogen?
Great question.
That's just one consideration. We don't. Somehow it's thought that it's the oxygen that gets from our lung, from the alveoli in our lung to the capillaries. But that's one question. Another question, or another observation that leads you to question is fish. You know, some fish thrive at depths that go down to 5 miles. There's not much oxygen down there. Measurements have shown very little oxygen. And in some places in the ocean, there is some mixing, but there are some places in the ocean that measurements have shown essentially zero oxygen. And so the question is, how do fish make it? How do fish do it there? Now, if you think about the fish, what they do is they, quote, breathe in water, right? They take in water,
Yes.
and then the water comes out of the gill slits on the side. Now, the water that comes out, people have measured the pH, and the pH of the water that comes out is lower than the pH of the water that comes in, which means positive charge. The water is losing negative charge, right? Because the water that comes out is more positive than the water taken in. So the fish are somehow utilizing the negative charge for something, and I think that something is to nourish the tissues which need negative charge. So somehow, as an example, the fish thrive perfectly well on essentially zero oxygen, but they can get negative charge from the water. It's drawn from the water, and the way it's drawn is through the gills. From the gills are able to take the water and create electrons, and surrounding the gills is a capillary system. So it's one example of how the idea that the coin of the realm is not oxygen, but negative charge from the oxygen or from the water, or wherever you can get the negative charge. It's the negative charge that really is needed by the tissues. And so I know it's a radical idea, but
well, isn't the hydrogen the negative charge?
No, hydrogen is positive charge. So the water would break up into H plus and OH minus. So the hydrogen would be a positive charge. And so, yeah. And so the water that's expelled in terms of the fish through the gill slits has more positive charge, more H plus. That's what measurements have shown. And therefore, you know, you've got to compensate for that some way. There has to be, if you're expelling positive charge, you must be taking in negative charge, because the water molecule that's taken is neutral, right? And if you got positive expelled, then you must have negative that goes somewhere. And the argument is that it goes to nourish the tissues in the fish. And so, you know, I realize this is a radical idea, but I think it has some merit. Otherwise, I wouldn't have put it forth.
So where do you think that negative charge is coming from?
Well, see, so it comes from the water. So the water then splits into negative and positive. The positives come out of the gill slits, and the negatives are used by the fish to nourish the fish. We know we need sort of vaguely, we need negative charge, but I think we need negative charge more directly. And this negative charge is used by the fish to nourish the tissues. The fish can't get oxygen, because there's no oxygen down there yet. The fish thrive. They seem to, and I'm using fish as an example that one doesn't need oxygen to survive. I think we need electrons from the oxygen. And so I'm not sure where.
Well, what's the best way for us to increase then the electrons?
Oh, well, we can we can breathe higher oxygen content. We get more electrons from that. Higher pressure, I suppose, will do it. I start thinking of hyperbaric oxygen therapy, where it treats so many syndromes way beyond the original. It was used first to treat wounds that wouldn't heal otherwise, military, and it turns out that it's useful for numerous kinds of issues that afflict us. And that's what research has shown. And we wondered how could it be so diversely effective? And we studied hyperbaric oxygen therapy. So we found that the high oxygen builds EZ, and the high pressure that's characteristic of hyperbaric oxygen therapy also builds EZ. So both the high oxygen and high pressure build the EZ water, which we absolutely need in our bodies to run our bodies. Our cells are filled with EZ water, and the EZ water is essential for function. So if we have impaired function caused by diminution and the effective or the ideal amount of EZ water in our cells, restoring it through hyperbaric oxygen therapy should heal us, and it's been shown that it does.
So the EZ water is the fourth phase of water, this gelatinous phase.
Yes.
Is that a higher level of charge in EZ water?
Yes. Well, it's more EZ water, and it could be a higher charge in the EZ water. See, the EZ water consists of, as I mentioned, oxygens and hydrogens, and the oxygens have 5 different oxidation states. So if you pump in more electrons, the oxygen can be more negative, and therefore the entire EZ will be more negative. And that should be a bonus for health. So you need EZ water because what the cell does, this I elaborated on this in my 2001 book, Cells, Gels, and the Engines of Life, that the action of a cell involves a transition from structured, or now we say EZ or fourth phase water, to ordinary water, and then back again. So like, for example, if a muscle contracts, when it's in the relaxed state, the cell is filled with EZ water, and in order to activate it, nothing can happen in EZ water. It's sort of like ice. Everything is kind of static. Molecules can't move around. They can't go in the cell, out of the cell. But the cell then transitions from ordered EZ water to ordinary liquid water, and that's the trigger for the start of, say, muscle contraction or secretion, or depending on the particular kind of cell. And then when the action of the cell is terminated, the cell returns. The water returns to its ordered easy state. And the proteins actually change their configuration from a contracted protein back to extended protein. That's the cycle that I believe the evidence is suggesting that all cells go through to do what they're designed to do. So it all starts with easy water. And if you don't have a full complement of easy water, your cells are going to be dysfunctional or even pathological. So the idea is to refill your cell with easy water. And there are at least a half dozen simple ways of doing that to restore that easy water.
Please tell us, what are those simple ways?
Number one, drink a lot of this stuff.
Okay.
Right? Because when you drink this stuff, it's called water. And some of that water that you drink will convert into easy water naturally. As I said, what it needs is hydrophilic surface and infrared energy. And we've got plenty of infrared energy coming from outside and also coming from inside, from metabolism, from heat of metabolism. So we can get more easy water in our cells by drinking this stuff. Second way is through juicing. And I know, as many of you know about juicing, you run into your backyard, take the leaves of freshly grown plants, vegetables, smash them, grind them, and squeeze out the juice and drink it. Now, what is this juice? Well, the juice is actually the contents inside the plant cells. And these are freshly grown plant cells, and the interior is filled with easy water. So you're essentially drinking easy water. And it's not the easy water itself that somehow works its way into your cells. It's the negative charge from the easy water. I believe, we've shown that if you put negative charge into water, that negative charge transitions the liquid water into easy water. We have direct evidence for that. So when you drink this kind of juice, which is filled with negative charge, from easy, the negative charge seeps into those cells that need negative charge and builds easy water. And that's why I know many health practitioners report that it doesn't matter what the patient is complaining of. They say, start drinking, start juicing. And then they come back a few months later and they're better. So that's a second way. A third way is a sauna. So what's a sauna? Basically, it's heat, right? It doesn't matter whether it's dry or moist. And that heat is essentially the same as infrared energy. So you're bombarding yourself with a practically infinite supply of infrared energy. Infrared energy builds easy water. And that could be the reason why you go into the sauna feeling tired and depressed and muscle pains, and you come out feeling like new, and so that's another way. Grounding yourself.
What about infrared lights?
Well, yeah, I mean, that's pretty much the same as an infrared sauna, or as the Finns say, sauna, or as the Russians say, banya. They're all basically the same. And yeah, and you can buy infrared lights. And, a number of physicians have told me, there was one in particular, I met a physician in Germany after a conference, and the guy was telling me that he treats cancer with infrared light. And he said he treats mostly young women who have some kind of cancer on their face. And they don't want surgery because they don't want to be disfigured. And he told me he treats them with infrared lights. And he said it's remarkable. They heal. No surgery necessary. And, and healing from the point of view of what we've discovered is largely the buildup of easy water when you don't have enough easy water. So that's another way. And finally, I guess, grounding or
Earthing.
The Europeans say earthing, earthing, connecting yourself to the earth. So why does that work? Well, it's been researched for quite a number of years, and there are a lot of theories. And of course, I have one too. And the theory is actually very simple. The Earth is negatively charged. Many people don't know this, but because we don't learn it in school. But the evidence is profound. The Earth is not neutral; it's negatively charged. And so, if you connect yourself electrically to the negatively charged Earth, it means you're connecting yourself to essentially an endless supply of negative charge. So negative charge seeps into your body, builds easy water, and that's why you feel better if you ground yourself or if you connect yourself to the earth. And that can be done in any number of ways. I know my son does it. He sits at the computer all day, and so what he did was to drive an iron rod 6 feet long or so into the earth and connect it electrically to an aluminum plate. And he rests his bare feet on the aluminum plate and he feels better. And all kinds of positive effects of earthing have been reported. And I think it's as simple as the buildup of negative electrical charge in your cells, because that builds easy water, and the easy water is critical for function. So I think
Thank you,
stop
Jerry.
the lecture there. Pardon me?
Yeah. One other thing, could you talk about waterfalls?
Yeah, waterfalls. You feel good in the presence of a waterfall, and I don't rule out psychological factors, but there also are physical factors. Waterfalls are little droplets that form in the vapor, and we found experimentally that these droplets contain negative charge. And the reason each droplet contains negative charge is that the droplet consists of an onion-like skin and a hollow inside, and the inside is filled with positive charge, and these layers are actually EZ layers, and that's what confers sphericality to these droplets. And we found that the negative charge exceeds the positive charge, so each of these droplets has net negative charge. So we go to the waterfall and we breathe in these aerosol droplets, these tiny droplets, consisting mostly of negative charge, and we feel better. Is that what you
Yeah.
referring to?
Yeah. It's great. Thank you for explaining that. Mary, you want to ask Jerry about the about nanobubble technology?
Yeah, I'm glad that you've addressed most of my questions. I love the earthing details, but this idea of a friend, Victor Golahan, looked for a means to address altitude sickness, and he found nanobubble infused water. You can see it called inspiredwaters.com, and it's marketed now in Russia, not yet commercialized here in the US. They're looking for commercial support if there's someone who has interest in this, but it basically, I guess, addresses maybe the oxygen needs through the electron. Maybe you know more, Dr. Pollack.
No, I haven't heard about this, but yeah, but again, reverting to the idea of negative charge, this might contain negative charge, and I hadn't thought about altitude sickness. Yeah, so the nanobubbles would be the same as droplet, and whether it's a droplet or a bubble, the two are actually pretty hard to distinguish. In the laboratory, sometimes we would see what we thought was a bubble in water and turned out to be a droplet, and so it has the same structure. It has negative charge around the periphery and positive charge in the core, and I don't know, I can't say always, but I think almost always the negative charge exceeds the positive charge. And so if high altitude sickness, if there's a deficiency in the amount of oxygen, and therefore, in my view, the amount of electrical charge, adding negative charge in the way that these nano bubbles might do, it's easy to understand, how that would help. So it makes total sense. And it doesn't surprise me that the Russians have adopted this, but the rest of the world, not yet. The Russians are often in the scientific arena, maybe more advanced than a lot of the rest of us. I'm not sure why, but the Russians have done great science.
Stuart?
Yeah, Robert, hopefully we can hear you.
I can, yeah, I changed my my connection. The nanobubble technology is quite developed. The Japanese are definitely the leaders in nanobubble technology, especially in terms of nanobubbles of the gases oxygen and hydrogen, which are introduced into baths. And people will experience these baths, and they have incredibly health benefits, much like grounding and the other therapies that Gerald had. So there are also nanobubbles in the famous cocoon baths. That Cocoon is the famous Hungarian spa that now has various spas, like the biggest one is in Las Vegas, the Cocoon, K-A-Q-U-N. And they also make a special bottled water. There is some kind of magic to gases, especially oxygen and hydrogen and nitric oxide in water when ingested. And as well as soaking in these baths. These are very famous. Everybody should look it up and see what they're doing. And they electrolytically prepare the water with special catalytic metals such as palladium and platinum that generate these nanobubbles of the gases in water. And it's extremely therapeutic. And there's tons written on it and many studies done.
Thank you, Robert. Thanks for sharing that. Gerald, one other topic is the oceans, and the oceans as a source of energy, and love for you to talk about that.
There I revert to the Israeli connection, and I remember swimming in the Dead Sea, and the Dead Sea, you can't sink in it; you basically float, and which means the water is kind of viscous.
Yes, I've swam there too, and it's incredibly thick and actually stinging.
Well, I don't remember the sting, but it's thick and viscous, and therefore, this is the kind of water that seems like easy water, because easy water has the same characteristic, and the Dead Sea is full of salt. I don't remember. I used to remember the molarity of it, but I think it's like 2 molar or 3 molar or something like that.
Yes, it's of magnesium chloride.
Yeah. Okay. And so with this high salt concentration, it could be that the salt nucleates, the salt molecules nucleate the buildup of easy water, and that's why it has the characteristic that it has. And so that's the reason you won't sink in it. And so sorry, what was the question originally?
It's about the health benefits of, well, the ocean, whether it's the negative charge that's in the ocean and or the minerals, because there's over 90 minerals in the ocean.
Yeah, so the charge is what I had forgotten.
80 minerals and trace elements.
Yeah, I don't know if anybody's measured the charge in this water, but I wouldn't be surprised if it has a whole lot of negative charge. And Robert, maybe the pH of the water in the Dead Sea.
I don't know, but the effect of magnesium chloride at extreme concentration, which is what prevents you from sinking. It's generally attributed to the magnesium itself and the transdermal input of magnesium into the body, and it really mimics when you take a bath in Epsom salts, which is magnesium sulfate. It has the same calming, beneficial effect of the transdermal magnesium.
Oh, okay. Yeah. Okay. Well, so it would be interesting, to see if these bodies of water, like the Great Salt Lake and the Dead Sea especially, whether the physical chemical properties would be really interesting to measure. Maybe they have measured, people have measured it, but I haven't come across that.
Well, Jerry, let me regarding the Great Salt Lake. The Great Salt Lake, unfortunately, is the highest known level of methyl mercury in North America. So we don't want to soak in that one.
No, okay.
Robert,
I
could you
hear
talk about the ocean water and seawater and both the pH level and the well, I'll call it the energy that we get from seawater?
Well, there's a lot to be said about seawater, especially where the seawater is from. I represent the very world famous product, Canton Marine Plasma, that I brought here to America 20 years ago, and it has a history since 1897 as being one of the most therapeutic agents that one can use for almost every pathology. But the oceans generally, 8 to 8.4 pH, and which is nothing special. It contains, it contains 78 to 80 elements of the periodic table that are in solution, and the rest of the elements are gases. So we really don't talk too much about the benefit or the action of biological action of the gases in seawater. But seawater is magical, much like grounding and soaking in hydrogen and magnesium. And it's also, the ocean is very rich in magnesium at about 250 parts per million. And there is something, all throughout history. Even Euripides made the famous statement, "The sea cures all men's maladies," okay? And it has been used since the Vedic times. It's very thoroughly written about for its healing benefits, both orally and topically. And I think probably one of the biggest things to know is that for maybe 150 years, there have been something called thalassotherapy centers around the world. And this exposes you to many of the oceanic environments. So you're exposed to not only soaking in ocean water, but experiencing its mist and aerosols and breathing that in, which of course delivers electrons to the body as well. And, people should look up this term and maybe visit a thalassotherapy center. There's one that I visited on the northern coast of Spain that's spectacular. And so, you can't beat the ocean for delivering beneficial stuff for the body.
What was the word you mentioned, Robert?
Thalassotherapy.
How do you spell that?
THALLOSO and then therapy.
Okay.
Thalasso. THALLSO. You'll get it. I'm not sure I'm spelling it.
I just sent that to everyone, but that's good.
Okay,
Thank you.
cool.
Robert, you mentioned the pH of ocean water. I was unaware. If the pH is on the order of 7 or 8, then according to our measurements, the ocean should have net negative charge. And so I can understand how bathing in the ocean with all of that negative charge should be beneficial to health. And maybe
yes,
one of the reasons why we feel so good after
of
bathing.
course.
Yeah. Okay, we're on the same wavelength.
We are.
Yeah.
And that's my daily therapy. Being in the ocean each day for me is the most healing thing that I can do. Achim, you had any comments you want to share here?
Well, ocean pH is 8.1 at the moment. Well, it was 8.2. Obviously, we know all about the climate impact, CO2, and the impact it has, that the pH is going slowly down, and with all its negative impacts. I just posted something on the text. I didn't want to deviate from, because we've already moved on. It's just I still had some question marks around the earlier comment about that higher or lower pH has an impact on charging, or that then the water gets charged with a net negative or net positive. I would need to be convinced of that. What I can, however, say is, and that's what I posted, what you do when you deviate from the pH 7 up or down, you increase the amount of either the OH minuses by a lot or the H pluses by a lot, but they all will have counter ions. But they will be the sodiums and the chlorides and so on. But these are a lot slower ions. The OH minuses are the fastest negative ions in water. They're about 4 times faster than the next, like a chloride ion. And the same on the positive side. The H plus is like 7 times faster than the sodium in water. It means if you've got loads more of those positive ions, it's a lot more reactive to any other external impacts. If you have inductions, electric fields, or any motions going on inside, or magnetic fields, the H plus will be much more reactive, and the OH minus will be much more reactive than the sodiums and the chlorides and so on. And that's how I would potentially interpret this, that the measurement tools might have picked up these ones much quicker before an equilibrium could have been reached, for example, at the measurement electron. Because in dynamic states, this would make a difference. If you leave it come down back to a equilibrium, basically, it should make a difference. But that was almost a sideline. That was my comment that I posted.
I'm going to send you a copy of our paper.
Okay, will be good.
We test to see whether indeed pH is a measure of charge. Yeah, and then perhaps if you disagree, I'm happy to
get convinced.
Okay, sure, absolutely.
I like that dialogue. That's wonderful. So before we end, I just want to ask you, Jerry, what's the one message that you would like us and the world to know about water?
Well, that's a good question. You know, I thought the question would be, what would I like the rest of you to know about science? And I would have said, don't believe what you read in the textbook, because there's a good chance that it's wrong, because what's in the textbook is the product of humans, and humans are not infallible. So I would have responded that way. In terms of water, I think we've by now produced ample evidence that water has a fourth phase, not just solid, liquid, and vapor, but a fourth state in which molecules are ordered, and which has charge, and which has the capability of delivering energy, of storing and delivering energy. And I think, I guess that's maybe the main point, because it means that wherever you have easy water, which is almost everywhere, you have energy, energy that can be stored and delivered. And you know, up to recently, it hasn't been known that that's the case. And you know, if it's really true that the water is supplying energy, but you don't realize that you attribute the energy to some other source, explanations grow very complicated. And it seems, I believe that the explanations grow simpler if you're on to something that is correct. And I believe that the fourth phase represents a kind of a substrate for the storage and delivery of energy. And it's not just in the body, but it's all over our environment. And I've been gradually presenting examples of that, examples in many different areas. And so, you know, beyond just the body. And so I guess if you're asking for one take-home message, is that water has the capability, has a fourth phase, and the fourth phase has a capability of storing and delivering energy.
Beautiful. Well, you made me want to ask one more question relating to the fourth phase of water. If there are possibly, I've heard 17 phases of ice, is there a possibility we may discover, or you and others may discover, other phases of water?
How could you rule that out? We don't know what we don't know.
So are there many more phases of ice than as whether number 17 or not? Do you know?
I can't comment on that. Again, it remains to be discovered, and we can't predict what will be discovered in the future. So it's really not possible to answer that question. At least I have no answer to that.
Well, and as we look to water and we look to life, we keep looking to outer space and other planets and trying to find water on other planets. Maybe the life is contained in another phase of water there that we haven't quite discovered.
Yeah, it could be. And it even, most of us think that water is essential for life. And I used to think that water was essential for life too. And on the other hand, I think that easy water is essential for life because I think it's one of the main sources of energy we have for life. But one surprising finding that we had led me to question that, and that is we found the same sort of structure in not just in water, but other small polarized molecules like ethanol, for example, and several others. They exhibited the same properties, essentially the same properties as water. We found that there's an exclusion zone and a region beyond, and they're oppositely charged. And I could never have predicted this. And if this essential mechanism is essential for life, it may be that life could be built on ethanol. We wouldn't need to drink Scotch whiskey to enjoy our lives. We'd be built of it, essentially. So I, who can say whether there's a life out there that's built on ethanol or methanol or any of these small polarized molecules? I don't know.
Well, I love your humility and your curiosity. And as a scientist, as I think you've really inferred, that true science is being curious and being open to not knowing. And when we're open to that, then we have the capacity to take in so much more, not only knowledge, but possibilities. Because as we know, space is 99%, and we don't know. Most of the point is we just don't know what's there. And so to be open to that and to know that water is that most magical compound that we continue to not know and to learn from. And we're all so deeply grateful for you and your work, your passion, your commitment, and your openness and your curiosity and your brilliance and your wisdom. Thank you, Jerry.
Well, thank you, Stuart, for your kindness. I really appreciate that.
Thank you, Jerry.
Yeah, thank you. Thank you all. For sticking with it for 2 hours. I know your time is valuable. So,
yeah, well, we're grateful. Yeah, grateful to all of you, our community, being here and sharing. And we're looking forward to our next month. We're going to have a fascinating younger man, Tess Steinberg, be our host and speaker. And he's about to take on an event where he will be rowing from Hawaii to Australia for 4 to 6 months. And he'll be talking about his work with water and his experience with water, and particularly with the oceans and reducing plastics in the oceans. So we'll look forward to having you join us next month.
Thank you, Stuart.
Yeah.
Thank you so much.